Okay, let's just look at the decompositions of proper rational function. So proper rational function, if you want to decompose them, so you come across the three general cases. Okay, the first general case that you can see is the Q, that is your denominator, is a product of distinct linear factors. And what does this mean by distinct linear factor? That means that it's actually has different form of factors. They have different form of factors. For instance, you can see that I have at here, so I have a factor of ax plus b, I have a factors of cx plus d, and I have a factor of ex plus f. Okay, so those are different factors. Okay, and okay, let's just look at these factors. Okay, these factors, it has x power 1. So when you have x power 1 at the denominator, so at the top you should put constant. It should be 1 degree less than the bottom. Okay, so same thing, this is x power 1. This factor has x power 1. So therefore at the top you should have constant. So that constant is actually follow the alphabet. So you will have follow the sequence A, B, and C. Okay, for the second one is we refer to the Q is a product of distinct linear factor, but some of them are repeated. Okay, so for instance, you have this one. Okay, so this is ax plus b is one of the factors, and again we see ax plus b at here. The ax plus b is actually repeat. Okay, so if you compare with case number one, you can see that these two are different factors. They are different. This is ax plus b, this is cx plus d. But for case number 2, they are repeats, right? So this is actually repeat for the second time. Okay, once we have identified this is actually the case of repeated. Okay, so what happened to the top? At the top, okay, same thing. So you should consider what you have at the bottom. So this is denominator. Your denominator has x power 1. So at the top, you should put constant. So same thing happened to this one. So you have a square. Okay, even though you have a square here, but this square is belong to the bracket. What we should consider is we look inside the bracket. So look inside the bracket. You can see that we have a linear. So we have x power 1 inside the bracket is x power 1. So because this is linear, that's why at the top we put constant. Okay, for case number 3, you may come across irreducible quadratic factor. What does it mean by irreducible quadratic factors? It means that you may come across something like this. Okay, so you may see x squared plus x plus 9 is actually cannot be factor. Okay, cannot be factor. So that is referred to irreducible quadratic. Okay, let's just look at the form that you might come across later. So this one is the form is this combination of linear, this is linear, and this quadratic. Okay, so this linear equations, this is linear equation, so you have x power 1 at here. So therefore, at the top, you should have constant. But for this factor is quadratic. This quadratic, it has x power of 2. So when you have x power of 2, at the top, it should be x power of 1. So you should have linear. At the bottom, you have quadratic. At the top, you should have linear. You always must have 1 degree less than the bottom. Okay, at the top must be a degree less than the bottom. Okay, so and we see the alphabet is actually follow. Okay, it's follow the sequence of the alphabet. So F A and B X plus C and so on. Okay, let's just go to the example. Okay, look at this proper rational functions. Okay, at the denominator part, we have x squared minus x minus 6, and this actually can factor into x minus 3 and x plus 2. And okay, what you have to do is you change the denominator into this. Okay, so after you have changed the denominator into whatever that you have factor, okay, And then you have to look at the type of the factors that we have here. So we have distinct factors, means that you have different factor. Of course, x minus 3 and x plus 2, they are two different things. So when you have two different factors, then you should write your partial fraction as this. Okay, you take each of the factor become the denominator of the fractions. For x minus 3 become the denominator for the first fraction, x plus 2 become the denominator of the second fractions. So now this one is x power 1. The denominator of here is x power 1. At the top put constant. At here is x power 1 and the top is also put constant. So put the alphabet follow the sequence. So then the next thing is we have to multiply the denominator to the both sides. Okay, so you have the denominator that is x minus 3 plus 2. So take the denominator, multiply to both sides. So what happens when you multiply? So let's say you multiply the x minus 3 and you multiply the x minus 3 and x plus 2 to this side. So basically this one and this one you can cancel, this one and this one you can cancel. So whatever that remain is actually 13 minus x only. Okay, then we're going to repeat the same process again. So we're going to multiply the x minus 3 and x plus 2 to the right hand side. So you will have the x minus 3 minus cancel with this, and the things that remain is actually a with x plus 2. Okay, and then repeat the same process again. Multiply the last item that you see here. Okay, the last item that you see here. Okay, with the denominator, that is, you have x minus 3 and x plus 2 multiply with this fraction. So basically this one and this one you cancel. So the thing that remain is actually b and x minus 3 only. Right? Okay, so let me erase the thing. Right? Okay, so after we have multiply, okay, both sides with the denominator, okay, then you will have a new equation. Okay, a new equation. So this equation, you look at the left hand side and the right hand side together. Now what you have to do the next is actually try to compare the coefficients of the x and constant of both sides. Okay, we try to compare left and right. So we begin with the x. Okay, look at the coefficients of x. Okay, so look at the x. Okay, at the left hand side, the coefficient of x is actually minus 1. So you have minus 1 at the left. Okay, for the right hand side, let's look for the x. Okay, we just look at for the x. Okay, the x we have here, that is ax, but we don't write the x, we just write the a. So that's why you have a here. Okay, and then the next sign, we ignore this one. This is not x. Okay, so we go for the next x that you see here. So we have bx here. So just write the b. So we have plus b. So basically this equation you cannot solve. Okay, so we just name it as equation number 1. Okay, then we follow the next by the constant of this equation. So you have constant. So it means that Okay, left hand side. So left hand side, this is the constant. So this is 13. Okay, we will have the 13 at the left hand side. And how about the right hand side? So for the right hand side, look at the constant, don't look at the x anymore. So now you expand this one. So you have 2a, right? So just write 2a. How about here? So the next thing that you can see here is if you expand, you have minus 3b. So of course, we cannot solve this one. So we just name it as equation number 2. So for these two equations, in order to find the value of a and b, you have to solve it by using simultaneous equation. But how to solve it? So you can see that basically I have the same variable for these two equations. I have variable a and b for these two equations. Okay, what you have to do is try to make this one has the same coefficient as the bottom. So what you can think of is you have an a here, you have 2a. So try to multiply the number 1 with 2, just that you have 2a. Okay, equation number 1 with 2, so you have 2a. So when you multiply the equation 1 with 2a, so this one is basically give you minus 2, and this one is basically give you 2a, and this is actually give you 2b. So you multiply the equation 1 with 2. So I name it as 1a because I want to make it more easy to trace back, okay, when I want to check for the source. Okay, so now the next thing you should do is you have to minus down. So you just have to take equation number 2 minus equation number 1, equation 2 minus equation number 1. So when you minus, so you have 13 minus 2, so you have 15. And then we have the next, you have 2a minus with 2a, so you have 0a. So basically the a, it disappear. Okay, then how about here? So you have negative 3b minus with 2b. So negative 3b minus with 2b, so you will have negative 5b. So simplify this one. So this is actually give you b is actually equal to minus 3. So once we have the value of b, so we need to know the value of a. So you substitute your b equal to minus 3 into your number 1. So substitute into here. So when you substitute into here, so you have this one. Okay, so then your value of a is actually 2. So once we have known the value of a and b, then we have to write the result. So just now we says that, okay, you have the partial fraction as this one. So I just copy back. Okay, after you have copied back, do the substitution. So this is a is 2, substitute it here, and b is negative 3, so substitute at here. So then you will have this. This is the partial fraction. In second example, we have the case of repeated factors. Okay, if you look at the denominator, basically this is a case of repeated factors. When you have repeated factors, the way to write the partial fraction is actually like this. Okay, so you have to write the factors, okay, to the power that being given in the questions. Okay, so this is power of 2. You have a bracket, a power of 2. So you write the fractions. Okay, so begins with x plus 2 bracket power of 1 here, then followed by x plus 2 again for the second times, and power of 2 here. Okay, so now we only have 2 fractions because the highest power at the bracket is actually 2. Okay, so therefore at here is only until power of 2. Okay, and let's just analyze what is inside the bracket. Inside the bracket you have x power 1. Therefore, at the top, you should have constant. And this is actually x power 1. Therefore, at the top, you should have constant also. And the next thing, we're going to do the same thing. Okay, this is your denominator. So your denominator, you have to multiply both sides with the denominator. Okay, so take this denominator, put it here, and you multiply all of them with this denominator. So what happens if you multiply with x plus 2 squared? So you will have a result of this. Why? Okay, because you will look at the first item, this x plus 2 squared, you can cancel with here. So the thing that remains is actually x. And at the right hand side, the first fraction is, if you multiply this one with here, so this is x power of 1 and this x power of 2. So basically you can cancel it. Okay, you can minus it, so you only have x power of 1. Therefore we have a multiplied with x plus 2. So for these fractions, you can multiply with this. Okay, when you multiply with this, basically they will cancel. The thing that remains is actually b only. After you have simplified it, then you have to compare the coefficients of left hand side and right hand side. So we begin with the x. Okay, so begin with the x. So at here, at the left hand side, we have x is actually 1. At the right hand side, we have ax. The way to write is 1 equal to a. Why is 1 equal to a? Okay, left hand side for the x, the number or the coefficient in front of x is actually 1 here. For the right hand side, you have ax, right? We just focus on the coefficient, just look at the number, it's just a. Okay, then we follow by the constant. So for the right hand side, we do not have constant, we do not have numbers. Okay, so this means that you have 0. Okay, but for the right hand side, what we have here is actually, you can expand this. This is actually give you 2a, and then followed by, and the constant is actually b. So you expand this, you have 2a plus b. So we have the next line. So this is, we name it as equation 1. And since we already know a is actually equal to 1, so we substitute a equal to 1 into the equation number 1. And then we will have the answer for the b. So once we know the answer for the b, so let's just recall back the partial fractions that we have written just now. So this is the one. So you're going to substitute your a as 1 into here. And you're going to substitute b equal to minus 2 into here. So then this is the partial fractions.